All right, the last video we left off after example number 2. So this is part 2 of lesson 3.4. And we're starting at example number 3 on your note sheet, and it says solve with 3-variable system with infinitely many solutions. So for this one, it's a little bit different than with no solution, because if you go back and look at your diagram of no solutions, in this middle one, or the first one, for example, the green and the blue plane in this first one. So we'll say green is 1, blue is 2, and red is 3 in that first triangular diagram. 1 and 2 have infinitely many solutions, 1 and 3 have infinitely many solutions, and 2 and 3 have infinitely many solutions, but 1, 2, and 3 do not share any points. Okay, so with this infinitely many solutions, you need to double check all 3 have infinitely many, not just 2 of them, because that's not enough for the system since we have 3 variables and 3 equations. Same with the second one, red is 1, green is 2, blue is 3. 1 and 2 have infinitely many, 1 and 3 have infinitely many, but you need to make sure that 2 and 3 also have infinitely many. In this case, they don't, they have no solution. So if you were to do this on your quiz or test for your homework, and you said, since 1 and 2 have infinitely many solutions, then the system has infinitely many, well, in this case, that's not true. Okay, so let's go back and look at example 3. Okay, so we're gonna first use the elimination method, and we need 2 pairs of equations. So let's work with the first 2 because it looks like we can pretty easily eliminate y. All right, so I'm gonna rewrite the first 2. 2x minus 2y plus 4z equals 6, and 4x plus 2y plus 8z equals 12. So this is our first 2 equations. So it's not enough if we just get 0 equals 0 here. We'll see what we get. Okay, so our y gets eliminated, and we get 6x plus 12z equals 18. Okay, so we don't have a solution yet. And now we're going to tie in our next 2 equations. So whatever we get here, we'll have 3 equations. We're using all 3 of them. So whatever solution we get is the solution that we'll get for our answer. Okay, so the next one, 4x plus 2y plus 8z equals 12, and 4x minus 2y plus 8z equals 12. All right, if we add these together, we get 8x plus 0y plus 16z equals 24. And then we can combine our first equation with that. 6x plus 12z equals 18. So I'm going to use the elimination method. I'm going to eliminate my x. You can use elimination or substitution, it's up to you. I'm going to eliminate my x. And I'm going to do that by multiplying my first equation by -3, my second equation by 4. Okay, and then I'm going to rewrite those. So 8x times -3 is -24x. 16z times -3 is -48z. And 24 times -3 is -72. And then the second one, 24 plus 48, 24x plus 48z equals 18 times 4 is 360 minus 8 is 72. Okay, so here, 0, 0, 0. I get 0 equals 0. Now, I got this by using all three equations. So, my solution, 0 equals 0. This is many solutions. And actually, it's infinitely many solutions, because 0, 0 will always be true. Now, I needed to make sure that all three of my equations were used to find this. If for some reason, when I used my first two equations, if for some reason it ended up like 0x plus 0z equals 0, that's not enough. That's not enough. I need to do something involving the third equation before I draw that conclusion. All right, and then the next one is solve a system using substitution. This is a little bit simpler because you don't have to eliminate first. You don't have to get down to two equations of two variables. You can just work backwards with the values that you have. So we have z. We've already solved for z, or they have solved for z for us. So we have z equals -1. So we're going to go up one equation. And we've got y minus z equals 3. We're going to rewrite that and plug in -1 for z. So y minus -1 equals 3. So we can solve for y. So y plus 1 equals 3. Subtract 1 from both sides, and we get y equals 2. Okay, now that we have z and y, we can go back to the original equation and solve for x. So we've got x minus 2y plus 3z equals 4. We don't know x. We can substitute 2 in for y and substitute -1 in for z. So we've got x minus 4 plus 3 times -1, which is -3, and that'll give us 4. So we've got x minus 7 equals 4. Add 7 to both sides. We've got x equals 11. So now we have to go back, always go back, and double check your answer. So we've got y, we've got z, we've got x. Let's go back into our equation and make sure that this is true. So x is, what do we say x is? X is 11, y is 2, z is -1. So we got to make sure this is true for all of our equations. So 11 minus 2y, which we said was 2, plus 3 times -1, does that equal -4? Well, probably not, because I did not carry over my negative when I substitute this in. So just as a double check, 11 minus 4 minus 7, does that equal -4? No, it equals -14. So that's why we always double check. So I made a mistake. So I have to go back and I have to fix it. This should be x minus 2 times y plus 3 times z equals -4. So down here, x, when I add 7 to both sides, I should get x equals 3, not x equals 11. So x should equal 3. So now I'm going to go back here. I'm going to try it again. Okay, so does 3 minus 2y plus 3z equal -4? And does 2 minus -1 equal 3? and does -1 equal -1? Well, -1 equals -1, that was a given. 2 plus 1 equals 3. 3 minus 4, that's -1. -1 minus 3 is -4. Yes, all 3 of those check out. So always super important, go back and double check your work. But that's all the linear system using substitution. And really, you'll use substitution when you have one of those variables solved for already, whether it's with 2 other variables, or 1 other variable or no other variables. Like in this case, there are no variables. You can use substitution, but sometimes it's a little simpler to use elimination. So in your homework problems, you'll have practice with both methods. So please jot down any questions you have, and we can go over them in class next time I see you. Thanks.